Well, we have taken the Chapter 2 test and results are in your folder. And I'm recording this video in hopes that I have an opportunity to explain some of the things that perhaps you missed and that you seek out the opportunity to perhaps improve your score. So let's take a look at question 1. Question 1 says, give the equation of a line that matches the given information. So I'm going to give you some information and I want to come up with an equation that fits that situation. Big picture, the first part, A, I give you a slope and y-intercept. B, I give you a point that is on the line and the slope. Part C, I give you 2 points that are on the line. And then part D, I give you a table of values that all these points live on the line. So let's start with part A. There's multiple ways you can write the equation of a line. The way that we most generally do it in our class is in slope-intercept form. And it takes this form, right? We've got y equals mx plus b. X and y are our variables, and m and b are things that we call parameters, right? There's 2 parameters that define the line. One of them is the slope parameter, and we know that the slope is represented by the change in the y variable divided by the change in the x variable. And the other parameter is where it crosses the y-axis, the Y-intercept parameter. And that is a location, right? X is 0, and B is at that spot. So those 2 parameters will define a line. And it turns out, in part A, I'm given both parameters, right? I'm given the slope parameter, and I'm given the y-intercept parameter. So to write that equation of the line, I just need to put those 2 things together and write y equals up 3 over 5, 3/5 x, and then minus 4. So that's the answer for A. In B, I'm given a slope and a point that lives on the line. I'm not given the y-intercept, but somewhere there's a point, 9, 4, and I'm given the slope. The thing about being given a point is that it is an x, comma, y value that lives on the line. And the thing that's nice is all xy pairs that live on a line satisfy the equation of the line. All of them do. If a point is on a particular line, then its xy values makes the equation statement true. Well, this is the generic equation statement, y equals mx plus b. If I was to take the x and y from this point and the slope parameter that I already have, right, that would give me an avenue for figuring out my y-intercept parameter. So my y-intercept parameter is what I'm looking for here. I'm trying to figure out what b is, and I don't know what b is. So looking at the point that I have a y value of 4 for the point that lives on the equation. So I'm going to write 4 equals, and then I'm going to write my slope parameter, 2/3, and then the x value of the point that lives on the line. So there we go. I've got 4 equals 2/3 times 9, and then plus b. If I simplify this 2/3 times 9, that multiplication problem, it turns out 2/3 times 9, let's see, 9 divided by 3 is 3, and 2 times 3 is 6. So I have 4 equals 6 plus b. So to solve for my y-intercept parameter, I'm just going to take away 6 from both sides. If I subtract 6 from the right-hand side, I'm left with just b. And when I subtract 6 from the left-hand side, I'm left with -2. So my y-intercept parameter is at -2, and my slope parameter was already at 2/3. So putting those 2 pieces of information together, we can say that the equation of the line for b is y equals 2/3 x, 2/3 x, and then minus 2. Y equals 2/3 x minus 2. All right, let's look at part C. On C, I'm not given the slope, but I am given 2 points that live on a line. Well, if I have 2 points that are on a line, I can definitely use those 2 points to figure out the slope parameter. And I'll just remind myself that the slope is the change in the y variables divided by the change in the x coordinate. And if I take a look at the 2 points I have, right, each one has an x and a y. And I'm going to stack this other point down below here. I'm going to write this as 9, 4. And I'm going to go ahead and I want to really focus on where the y coordinate is, where the x coordinate is. And I need to figure out the change in my y. So the change in my y variables is going to be, I'll just take the top y, 25, and subtract the bottom one, 25 minus 4. And my change in x, I'll take the top y again, which is 6, and subtract the the top x value, which is 6, and subtract the bottom x value, which is 9. So what I have here is 25 minus 4, which is 21, and 6 minus 9 is negative 3. So I end up with 21 divided by negative 3. Well, 21 divided by negative 3 is negative 7. So I know my slope parameter, right, m, is negative 7, down 7 over 1. All right, so now that I know my slope parameter, I'm going to use that with either one of my xy points, and it literally doesn't matter which. Do it carefully, and you can verify that it will work. But I'm going to go ahead and take and write, I'm plugging things into this generic slope-intercept form, y equals mx plus b. I'm going to take and use, let's use the top point. I'll use the 625. So for that point, y is the number 25, and that equals m, which is negative 7, times x, which is 6, plus b. So if I simplify I find the product of the negative 7 times 6, that's negative 42. So I have negative 42 plus b, and of course the 25 still is on this side. So it looks like I'm going to add I'm going to add 42 to each side to get what b is. And if I take 25 and I add 42, 25 and 42, it's going to give me 67. So the number 67 is my other parameter. It's my y-intercept parameter. So if I look closely, I can see that I know my slope parameter, check. I know my y-intercept parameter, check. So now I can write the equation for this line, and it is y is equal to negative 7 times x plus 67. All right, and then finally for part D, we have a fairly large table, and we can pick a lot of these values. I will point out again that we have y's in the right column, x values are in the left column, and it doesn't matter which of these points I pick, right? I'm told that this is a line. I'm not asked to confirm it's a line, so I'm going to assume this is a line. Therefore, it wouldn't matter which points I pick. And I'm just going to go ahead and I guess I'll go this way. I'll go 13 minus 6, and I'll go 15 minus 30. So again, I'm looking for the change in my y variables divided by the change in x, change in y over change in x. Make sure I know where the y's are. Make sure I know where the x's are. To figure out the change, I'm just going to take this 13 and subtract 16. And then I'm going to take the 15 and subtract 30. So I think you can see where I'm reading. It's 13 minus the 16, and then over 15 minus 30. Well, 13 minus 16 is the number, that's just the number 3, right? 3? Negative 3, let's get that right. 13 minus 16 is negative 3. And then 15 minus 30 is negative 15. So I end up with negative 3 over negative 15, but I know 3 and 15 can be simplified, right? They have a common factor of 3. And since they're both negative, this is equivalent to 1/5. Okay, so I know my slope parameter. Slope is 1/5. That's what m is, my slope parameter. So let's go ahead and think about how I can use that to figure out my y-intercept. I will caution you, yes, there is a number 0 here, but remember, for this to be a y-intercept, right, x would have to be 0. So what you have here is an x-intercept. You know where this is crossing the x-axis, not the y-axis. So do be careful of that. I'll use, it literally doesn't matter, I'll use this last point, 30/16. And then I'm just I'll write it again, y equals mx plus b. I'm just memorizing this, practicing this, rehearsing this. My y value is 16. And I've got m, which is 1/5 times x, and then plus b. 1/5 of 30 is the number 6, so this becomes 16 equals 6 plus b. And if I remove 6 from each side, I have 10 on the left-hand side, and on the right-hand side I have b. So 10 is my my y-intercept parameter. So there I've got both parameters, the slope parameter and the y-intercept parameter. So you know what that means. We're ready to write the equation of the line. So I'll come over here and I'll write y is equal to 1/5 of x plus 10. By the way, it's really nice to kind of make it a habit of saying, am I right? Am I correct? And I'll write this down up here. I said y is 1/5 of the number x plus the number 10. It turns out these are very nice numbers for checking if this works, because it turns out all of these values are multiples of 5. If I put 5 in for x, right, 1/5 of 5 is 1, and 1 plus 10 is 11. If I put in 50 for x, 1/5 of negative 50, rather, 1/5 of negative 50 is negative 10, and negative 10 plus 10 is indeed 0. One last one, right, 15. If I plug 15 in, 1/5 of 15 is 3, and 3 plus 10 is 13. So I can see that this is doing precisely what I expected to do. When I put in my known x values, it's giving me the correct y values. And that's also true of this equation, right? This equation for C, when I plug in 6, that does give me negative 7 times 6 is negative 42. No, negative 7 times 6 is negative 42. And negative 42 and 67 turns out to be 25. So I do encourage you to kind of ask yourself, if I was right, what would that look like? All right, let's move on here. So B. A couple things I want to remind you of some order of operation. Let's make sure that we're evaluating grouping symbols first, looking at powers, considering multiplication, then division. There's two big grouping symbols, right? I've got a numerator and denominator. I need to know fully what the numerator is, and then divide by that denominator. Within that numerator, there is two addition problems, but I really need to focus in on this multiplication / exponentiation here first. The exponentiation is going to happen first, and when I substitute into a function, I always intend to. If I don't do it, I'm doing something wrong. I always intend to use parentheses to show exactly where my input value is going. So I am going to take very intentionally the number -3 and place it into this function. And when I look at this, I recognize that I'm not going to multiply 2 times -3. I need to square -3 first. I need to square that. And squaring -3 involves multiplying it by itself. -3 times -3 is +9, so this is going to become 2 times 9 plus 18 over 12. 2 times 9 is 18, so this becomes 18 plus 18 over 12. 18 and 18 is 36, so this becomes 36 over 12. And 36 divided by 12 is 3. please be careful when you're doing this. I think probably good advice is to use parentheses as I have here, and then don't be afraid to write several steps out. I know a lot of you will do the 2 times 9 and then see the 18 and make it 36 and divide by 12 all in one step. If I produce a record of it the way that I've done here, I'm likely to look at that and maybe convince myself, I think you did something wrong. So anyways, for a 2, when I evaluate that expression, I should get, or when I put -3 rather into that function, when -3 goes into that function, it gives me a +3 back as the output. Let's take a look at B. For B, I have, this seems straightforward. I am going to be squaring the number 5 and then taking away 10. So you can see I just wrote x in parentheses for it. X gets squared and then take away 5. When I square +5, I get 25. That's 5 times 5. And 5 times 5, 25 minus 10 gives me 15. So the output of this function should be 15. When my input is 5, my output is 15. Let's move on to the second page. On page 2, we're asked to identify the input that will produce the given output. So if you look at it, what I'm really asking you here is, hey, what value of x would I put into this function that would make this function give me back 108? What value goes in to give me 108? Another way of saying that is I'm really curious about what value of x will make 2x plus 2 times the quantity of 3x minus 2. What value of x will make that equal to 108? So I just wrote that equation. I'm trying to find a value of x that will make the definition for this function spit back the value 108. I'll go ahead and use the distributive property to rewrite this. This is going to be 2x plus 6 times x and then minus the number 4. And that equals 108. Let your eyes look at it and see what's happening here, but I'm multiplying, I'm distributing this multiplication problem across the 2 terms inside the parentheses, right? I've got a term of 3x and I've got a term of -2. When I combine my like terms now, I've got 8x minus 4 is 108. I can add 4 to both sides. That's going to give me that 8x is 112. And just confirming this with the calculator, if I take 112 and divide by 8, I do get the number 14. So x is 14. In other words, when 14 launches into this function, it produces an output of 108. So we would just write down 14 is the answer for A. 14 goes in, 108 comes out. Let's take a look at the next one. Same deal. I'm curious about what value of x will make the definition of this function, will make the -2x plus 52, what value of x will make that the same as 22? -2x equals, if I take the 22, of course I'm going to get a negative number, 22, and subtract the 52, it gives me the number -30. And if I divide both sides of this by -2, when I divide the left-hand side by -2, I'm left with simply x. And on the other side, when I divide by -2, I'm left with 15. So for question B, when 15 goes into that function, it produces an output of 22. So 15b, the input that we're looking for is 15. Right, moving on to question 4. Always fun. A lot of anxiety, not confidence yet, but perhaps we're getting close. So for A, the one mistake that I saw was mysteriously some extra factors of 2 showed up. And I think what's happening is it's an overgeneralization of the distributive property. We do not distribute a multiplication across a multiplication problem. And the reason why is they're just factors of each other. So what I think I saw happening was some of you threw an extra value of 2 in here, and that's not what's happening. If I was multiplying, for example, 2 times 2 times 7, right? This is 14, and 14 times 2 is 28. I would not multiply by another extra value of 2. Or maybe I could do this. If I had 2 times 3 times 5, that's just 15 times 2, right? That's just the number 30. I can get it by doing the 2 times 3, which is 6, and then I have 6 times 5 is 30. Or I could do the 2 times the 5, and I would get 3 times 10. But I'm not doing it to both, right? So I think the error comes from if I was to consider 3 plus 5, right? Well, this value inside is the number 8, and 2 times 8 is 16, right? This undisputed answer is the number 16. Well, if I distributed this 2 across the addition problem, right, 2 times 3 is 6, and 2 times 5 is 10, you can see I do get the number 16. This is 16 also. But that does not happen up here when these are all just factors and there's no terms, right? We do not, there's no such thing that it's not what happens. So, okay, beyond that, let's take a look at what we have here. We just have some things that are being multiplied together. We have a 2, and that looks like it's the only constant that we have here, 2, or coefficient, I should say, 2. And then I have some factors of 8. In fact, there's 8 factors of 8, and I'm multiplying by 2 more factors of 8. And if I was to count them out, all the 8s that are being multiplied, 8 factors of 8 times 2 more factors of 8, it's 10. So this is 2 times x to the 10th power. And then I have some factors of y. I've got y to the negative 3rd and y to the 5th. It turns out in this case, the y to the negative power is going to take care of itself, and this is just going to become y squared. So that is the answer for part A. Part A is 2 times x to the 10th times y. And I won't write it on the line here. For B, a great thing to do, right, is to first of all get rid of this negative exponent. And there's other ways I can go with this. I could take care of the 20 and the 2 if I wanted to. I do want to point out that this is not, you do not see this 2x, oops, where's my pen? This is not 2x that's being raised to the negative 7th. It's 2 times x that's being raised to the negative 7th power. So understand that this exponent of negative 7 is just applying to the x, and we understand that because in order of operations, our exponentiation comes first, or powers. And then this multiplication would be secondary. So let's clear this negative exponent. And we're going to clear the negative exponent by multiplying this by x to the positive 7th power. I specifically picked x to the 7th power because my goal is to neutralize, right? I picked x to the 7th because I want to neutralize this, maybe this is good. Yeah, I want to neutralize this x to the negative 7th. And I understand that via multiplication, x to the negative 7th times x to the 7th is x to the 0 power. And x to the 0 power, which is what this product is equal to 1. So that's why I picked x to the 7th. I have to do it in both the numerator and denominator. When I put a value of x to the 7th in both the numerator and denominator, you can see I'm multiplying by the number 1, which does not change the value of this expression. We're just changing its format. That's the beauty of multiplying by 1. It allows us to manipulate how something looks without changing what its value is. Okay, so across the top then in my numerator, I have 20 times x to the 10th power, and across my denominator, I have just the number 2. So if I was to simplify this one step further, I know what 20 divided by 2 is, right? 20 is 2 times 10 divided by 2. I know that 20 divided by 2 is 10. So I can write this as 10 times x to the 10th power. So this is my answer for part B, 10 times x to the 10th power. Notice how we got rid of the negative exponent. In part C, I'm starting out with a chunk of something that's being raised to the negative second power. And I don't really care what this is, right? The idea is that something is being raised. A green blob is being raised to the negative second power. So I immediately I'm thinking about my powers of destroying negative exponents. So I bring in this. I'm bringing in this giant 1, right? And yes, the green blob lives in here. The green blob lives in here. But the beauty of this is at this point, right, no longer do I have a negative exponent. It's gone. You know it's gone. I know it's gone. It's gone because when I multiply these things together, I get green blob to the 0 power. And green blob to the 0 power equals 1. So in my numerator now, I only have the number 1. And in my denominator, I have 3x cubed. But I do need to square that, right? I've got 3x cubed squared. Now, to square this, right? To square this means that I'm going to multiply it by itself. And I can show that by writing 3x cubed times another 3x cubed. So if we look closely, I have 2 sets of the 3x cubed, exactly what I'm supposed to have, right? I have 2 sets of the 3x cubed. Another way to think about this is I could square the 3, right, times the x cubed also gets squared. But if you look, that's exactly what I have, right? Because I have 3 times 3, which is the 3 squared, which is the 9, times x to the third, x to the third, x to the third, which is x to the 6th power. So in total, I have 1, 2, 3, 4, 5, 6 factors of x. 1, 2, 3, 4, 5, 6. And you can see there are 6 factors of x. So my final answer ends up being 9 times x to the 6th power. That's our answer for part C. And the final part for D has another expression that has a negative exponent, but this time, at this point, we're just laughing at them like, ha ha ha, you think you're a negative exponent. Well, you are. But ha ha ha, you think that intimidates me. And the truth is it does not. I see that I have b to the negative 6th power, so I'm immediately bringing in a b to the positive 6th power in both my numerator and denominator. When I multiply b to the negative 6th times b to the 6th, it's b to the 0, which means it's just now the number 1. That's what it is. So in my numerator, I now have 5 factors of x times 6 more factors of x, or of b, I should use the correct variable. I have 5 factors of b times 6 more factors of b, which means I have 11 factors of b. b, 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 b. Actually, that was 11, I'm pretty sure. In my denominator, I have just a to the 3rd power. It was down there. It's still down there. It never had a negative exponent. It wasn't part of this to this negative 6th power because there's no parentheses. So we're done with that. And this turns out to be the answer for part 4, or part D rather, of question 4. Let's move on to question 5. So for question 5, we have 2 little equations, and we're asked to solve for x in both. Solve each equation for the given variables. So I guess the only variable I see is x, so I'm going to assume I'm solving for x in both. Let's start with A. In A, I am going to rewrite this using the distributive property. I am going to distribute this multiplication across the subtraction problem. So this is going to become 4 times x, and then 4 times negative 2, which is going to be negative 8. So 4 was multiplied by both the x and the negative 2 to give me 4x minus 8. The other side is just 20. I'm going to add 8 to both sides, which gives me that 4x is equal to 28. And if I divide both sides by 4, I get that x is the number 28 divided by 2 divided by another 2 is 7. Yeah, half of that's 14 and half of that's 7. So x is the number 7. Just for fun, I can come up and just place the 7 in here mentally. 7 minus 2 is 5. 4 times 5. 7 minus 2 is 5. 4 times 5 is 20. Yeah, when I put 7 into that equation, it makes both sides equal to 20. Let's take a look at part B. It's a bigger equation. There's a lot of equationing going on here. But I'm going to use pretty much the same technique. I'm going to begin by distributing this negative 3 right across the two terms I see. There's a 2x and there's an 8. So this is going to become negative 2x. Right, it's there. I'm going to leave it there. Negative 2x. And then I will have minus 6x. And then minus 3 times 8, which is negative 24, plus 11. Over on the other side, I'm going to distribute this 2 across these two terms. There's a x and there's a negative 5. 2 times x is going to be 2x, and 2 times negative 5 is negative 10. Over on the left-hand side, I can see that I have some like terms, right? There's negative 2x and 6x. There is also a negative 24 and a positive 11. So when I combine my terms that involve x, I end up with negative 8x. And when I combine the terms that involve the constants, right, 24 and negative 11, I know it's negative, and if I subtract it, it's, what is that, 13? This is negative 13. 24, negative 24 and 11. On the other side, there's nothing that I can simplify, right? It's just a 2x plus 10, so that's just left alone. So I'll just go ahead and write that equals 2x and minus 10. To clean this up, let's see. Lots I could do. I'm going to choose and take away 2x from both sides. So when I subtract 2x from the right-hand side, it just leaves me with negative 10. And when I subtract 2x from the left-hand side, it's going to leave me with negative 10x. Right? Negative 8x minus 2x is negative 10x. And then minus 13. And then let's add 13 to both sides. So this is going to become negative 10x. There's no more 13 because I'm adding that. And on the other side, negative 10 plus 13 would give me positive 3. And then as a final step, I'm just dividing by negative 10. So x will be 3 divided by negative 10. We can write that as negative 3/10. You could write it as a decimal as well, but to be honest, I like these fractions, right? Negative 3/10. And it actually takes less work. I just write it down. I don't have to grab a calculator and plug it in. Okay, page 3, question 6a. So I'm giving you values for 3 variables for an a, b, and c, and asking you to evaluate 2 expressions. Whenever I'm doing these substitutions into an expression, my recommendation is always parentheses. So in my numerator, I have 7 times open parentheses. Here's a set of parentheses just for the negative 4 that represents a. That's the value of a. Plus a set of parentheses for the value of b. Close that, and then I've got plus 5. So that's my entire numerator. In my denominator, I have 2 for c and then plus 1. So as I look across in the numerator, I can see that, well, if I combine those, and I need to combine those, I get positive 1. Negative 4 and 5 is positive 1. Well, that just means that that's 7 plus 5 in the numerator. And in my denominator, I have 3. And yes, 7 plus 5 is 12. And 12 over 3 is the number 4. So with those values, a, b, and c, and this expression, right, I get that the expression evaluates to 4, so I'll just write it right there. Now let's look at part B. For B, same thing, except I am going to be squaring something. So let's look at this first. Again, big parentheses here. I've got 2. Here's a spot for B, plus here's a spot for A, which is -4. Close the parentheses. I'm going to square that result. Plus 4 and then -5 times here's a spot for C. So in my parentheses, I've got, this is clearly 10. 10 minus 4 is going to be 6. So I'm looking at 6 squared plus 4 minus 10. 6 squared is 36 plus 4 minus 10. 36 and 4 is 40. So I've got 40 minus 10, which means I am left with 30. So when A, B, and C are -4, 5, and 2 respectively, this expression has a value of 30. And I can write that off to the side. 30, not something that could be confused with 36. Next, find the equation of the line that goes through 2 points. This feels a lot like the first page, and it is a bit redundant. But again, this is just another opportunity to show me how wonderful you are and find the equation line that goes through these points. I'm getting fond of stacking these, so I'm going to write my second pair of coordinates here. And again, I'm looking first of all for the change in my y variables. I'm going to divide that by the change in my x variables. That will allow me to see the slope of the line that connects these 2 points. And I will point out to myself that these are the y's and that these are the x's. So for my change in y, I'm going to take 15, the top number, and subtract 10. And then I'm going to take 42 and subtract 12. 15 minus 10 is 5, so I've got 5 in my numerator. And 42 minus 12 is, what is that, 30? 42, of course it's 30. So I've got 5 over 30, not 60, 5 over 30, and they are both positive, and they both have a common factor of 5, right? I can rewrite that as 5 over 5 times 6. So I have a giant 1 here, but my slope pattern clearly is up 1 over 6. So now I know one of my 2 parameters. I know my slope parameter is 1/6. I just need to figure out what my y-intercept parameter is. And I'm going to do the same thing I did before. In fact, I'm going to use this point right here. I could use the other one. Maybe you want to use the other one to make sure you get the same answer. But you can see from that point, I've got a y value of 15. I have an x value of 42. And I already know my slope parameter. So I'm just going to put things into this. Y is 15 equals m, which is 1/6, times x, which is 42, and then plus b. 1/6 times 42 is the number 7. So I'm looking at 15 equals 7 plus b. And if I take away 7 from both sides, 15 minus 7 gives me 8. So 8, my y-intercept, is b. So there we have it. We have both our slope parameter and our y-intercept parameter. So now we can definitely write the equation of this line. The equation of this line is y equals 1/6 times x plus 8. And a great strategy, right? If you're concerned about whether or not you made an error, a great strategy is to come in and look at your answer and just plug in these numbers and make sure you get the right things. And yeah, if I put 42 in there, that gives me 7. 7 plus 8 gives me 15, so that completely checks. Also, if I take 12 and I put it in there, 12 times 1/6 gives me 2, and 2 plus 8, it gives me 10. So these 2 points satisfy the equation of this line. They definitely live on that line. That line contains them. Final problem on the test was a fairly simplified dimensional analysis problem. I decided to give you one where we were just converting one of the units. I'm giving you that 258 gallons per week, and I just want that converted into gallons per hour. So if we write this down, 258 gallons per 1 week if I wanted to. Gallons per week is the same thing as gallons per 1 week. And I want my time to change. Instead of weeks, I want these to be hours. So a couple giant ones that would help. First of all, I observe that week is in my denominator currently, and if I want to move away from that, I'm going to place weeks in my numerator. And I know very clearly a giant one I can build using that. I can use the one that involves days. And in fact, it is a fact that 1 week contains 7 days. So this is the first, and I think the first of only 2 giant ones necessary that I'm multiplying this by. The idea is, just like before, when you multiply by 1, you're able to change the format of something without changing its meaning or its value. So I'm going to be going to gallons per hour, but it's going to be the same volume of whatever it is. If this is water or gasoline, it's going to be the same thing. So my other giant one I'm going to use is going to be the one that involves days. I want to move away from days now. Days is in my denominator, so I'm going to put days in the numerator. And I know a giant one I can build that involves days and hours. In fact, 1 day is the same as 24 hours. So here we go. This is still 1. These are both the same amount of time. A day is exactly 24 hours, so I really am multiplying by 1. But at this point, I want to point out that some good things have happened, right? Just focusing on the units, I've got week in the denominator, week in the numerator. Those are gone. I've got a day in the denominator, a day in the numerator. Those are gone. Those form giant ones themselves. What I'm left with, right, in the numerator is I've got 200, let me go back to the black pen. I've got 258 gallons. And then I've got times 1 times 1. So I can put that times a 1 times another 1. Doesn't change anything. And in my denominator, I've got 1 times 7 times 24. And then those are hours. So the only thing I have left are gallons per hour. But I've got to figure out the numerical part. So in my calculator, I need to multiply 7 times 24 because I'm feeling tired. 7 times 24 ends up being 168. So what we have here is 258 divided by 168, and these are gallons per hour. And let's go ahead and just convert this to a decimal approximation. So 258 divided by 168, and I'm just going to take it to 2 decimal places. So I'm going to write 1.54 gallons per hour. And there we go, right? So 258 gallons per week is the same as more than 1.5 gallons every single hour, right? There goes a gallon and a half. There goes a gallon and a half. And we are done. That is it for the Chapter 2 solutions. If you are interested, please talk to Mr. Roberts and ask about opportunities to earn back some of the points from the Chapter 2 test that you might have missed. I'll look forward to seeing you online and in class soon. So until then, goodbye.